G'day everyone, welcome. Today I've got Guillermo Miro with me from Attend2 Technologies. They do kind of online sensors and all that kind of stuff for oil condition monitoring and things. I think people are probably most familiar with uh, online sensors when it comes to vibration analysis, right? That's sort of the paradigm that people think of, but this is a slightly different application which might be new to quite a lot of people. So I'm really interested to get into this with Guillermo. So Guillermo, welcome. And if we can just get straight into it, maybe the first question I'd really sort of like to ask you would be the idea that oil condition monitoring hasn't significantly changed for a very, very long time.
Mm-hmm.
We take a sample bottle, you go and take a sample, 100 mils or whatever it is, you send it to the lab, you get your report back. Most people look at the report, and if they see a box that's yellow or red, then they go and they take action. That hasn't
Yes.
changed as far as I'm aware for many, many years.
Mm-hmm.
So why have things changed now? Why are we starting to see a few companies offer online oil monitoring? And
Mm-hmm.
what are some of the technologies that needed to be developed in order to provide this to the market?
Mm-hmm. So thank you, Rafe, for inviting me to these conversations. And you asked me a lot of questions in one, so I will start from the beginning. So condition monitoring, especially for lubricants, is decades old. So the sensors have just appeared in the last 10 to 20 years to cover some of the aspects that the lab analysis cannot cover.
Mm,
Especially, for example, uh, some issues that are well known in the industry. For example, good practices, no sampling good practices, or instead of measuring the fluid, measuring what is really in the equipment in different conditions. No, that sometimes lab analysis cannot deal with that. So sensors at the moment are a complementary tool to the lab because they are offering different type of data, but they cannot deal with all the data or all the types of parameters that the lab can offer. So some of the failure modes or some of the information that can come out from the lubricant is not available online at the moment.
mhm,
So with the technologies that has enabled this appearance or this creation of these online sensors is the electronics evolution. No, so
mm.
as I mentioned, the law of Moore. So every time the chips are smaller, are cheaper, are more powerful. So let's take a look just at the mobile phones that we have right now. So, and I remember a case from oil condition monitoring. Our first devices for the R&D prototypes were a shoebox, and now the sensor can fit in your hand. The same device, even with more powerful tools. So, this evolution in terms of reduction of price and reduction of size and increase in robustness, this is what has led to the let's say to the boom of online sensors in the market.
Okay, so for the most part, it's miniaturization, um, just of chips
Mm-hmm.
and things like that, um, which I guess is a pretty common theme across a lot of industries, right? And so we see
Mm-hmm.
electronics cropping up in many many places. So, uh, what what kind of sensors are they? So, what exactly do they measure? Because I think again, most people's conception of oil condition monitoring is going to be the raft of ASTM and DIN test methods that are performed in
Mm-hmm.
a lab. We're obviously not
Mm-hmm.
miniaturizing a lab and putting it into the flow
Mm-hmm.
stream. So, what is it that we're exactly measuring, and what kind of sensors are enabling that?
Hmm. So when I try to explain the let's say the sensor family, no, the variety of sensors that are in the market, I focus on the issues that they are measuring. So I typically explain that there are four types of sensors. No, so for example, let's say there is one type of sensors that they are, let's say, physical property sensors, measuring viscosity, measuring density, measuring heat modules or thermal properties, but these sensors are used for this they are used for measuring these properties only, no? And as we know, viscosity alone cannot explain a lot of failure modes of the lubricant or issues on the equipment, but they measure really well these parameters. Then we have, based on the same technology that you can have in a weather station, for example, there is the moisture sensors that they are specifically addressing water contamination in oil. Okay, so they are not all sensors, but they are conductive sensors that are able to measure the relative humidity of water in oil. So as soon as you have it submerged in oil, you measure the amount of water that is dissolved in the oil. It can help you to understand how much water do you have, for example. And then the two main or the two most widely applied sensors are the degradation sensors and the contamination sensors. Okay, so degradation sensors, probably we'll get into the last part because it's the most difficult to explain. So contamination sensors are sensors that are focusing on solid, or let's say solid contamination on the fluid. No, we can measure wear particles, we can measure other types of contamination. With the depending on the sector, there are other natures of contamination, no? or other types of contamination that can be present. And typically, there are two main types. So let's say electric magnetic based properties. So they are measuring changes in electrical eddy currents in magnetic fields to get information about the particles that are passing through, okay, size, materials, and so on. And then we have the other part that are it's called the particle counters. No? So they focus on measuring the size and quantity of particles for a typical range of micron size.
So just to
Okay.
jump in there, the maybe equivalent in the lab world that we're all familiar with is that one is a little bit like an optical particle counter, right?
Mm-hmm.
Which, ISO 4406 or whatever,
Mm-hmm.
shining a laser through and detecting when something passes through the beam, versus
Mm-hmm.
the the other type of sensor that you were talking about, which is maybe more analogous to the PQ index.
Mm-hmm. Yes, yes,
Not
but
obviously an exact comparison, but
yes, yes.
something
But
like
for
that.
example, PQ index is catching every type of metallic particle for every
Yes.
size, and these sensors, these magnetic field sensors, at the moment, they are measuring particles higher than typically dozens of microns. So we are 70, 50, 100 microns. So they are they are catching another type of issue that is the wear progress. No,
Okay.
so they are just catching very big particles that they typically come from when the wear issue in an equipment is severe or is medium severe. So so this correlation it's good. So the particle counters are the what it's at the moment the most similar thing to the lab in
Hmm.
terms of correlation. Some a lot of optical sensors are offering ISO 4406 measurements, so typical 4614 microns codes, cleanliness codes. But I would like to add that there are different technologies in the lab and there are different technologies in the market. No, it's not the same to give an ISO 4406 code with an automatic particle counter, typically light extinction, particle counter that give an ISO 446 code based on microscope based particle counter. One of them is what you mentioned. You pass light through a cell and you measure the size and the amount of obscurity means there are more particles for this size. But the microscope is filtering the oil and getting it into the patch and just taking a picture and analyzing all of the
Mm.
data. And in the sensor field, we have the same difference in technologies. Most of the sensors are laser or light extinction based sensors, and other sensors are digital imaging. So it's pretty similar to what is done with the microscope. Okay.
Yeah. Okay. Okay.
But in general terms, yes, we have the visible or optical particle counters and the
Yep.
magnetic particle counters.
And then maybe just
And the
one other.
last,
Sorry,
mm,
one other question I was going to ask was on the water detection. So
mhm,
you mentioned it's kind of measuring the conductivity of the fluid,
mhm,
which I guess would make sense. Water being a much more polar molecule than the oil, the more water you have, the more conductive the overall fluid is going to be.
Mhm.
How are we correcting for, let's say, for example, polar contaminants that come into the oil?
Yes, the point here is that it's, as I mentioned, is a similar process to the weather station. So you are
Mm.
just measuring relative humidity. So
Okay.
it can be affected by some contaminants, and also you cannot have a direct correlation with volumetric water content, for example, ppm that you can measure with
Right.
Calfisher, for example.
Mm.
You need to create an algorithm that correlates the amount of saturation level of the water content with respect to the ppm that you can find in this oil. But this is also temperature dependent. So the
Mm.
higher the temperature, the more water can ingress or can absorb the oil. So that's why typically these sensors are used to monitor water, no water, no, or the evolution of water, but without any correlation with some lab analysis. No,
Okay.
it's difficult to correlate with lab analysis.
Mm.
And then, last but not least, we have the degradation sensors that recently has appeared some lab-like sensors that are mimicking what is done in the middle infrared with the FTIR,
Hmm.
but the vast majority of sensors at the moment, they are just measuring, let's say, optical or uh, electrical properties, and they are converting this into with their own algorithms, they are converting it into indexes,
Okay.
percentage, numbers. So they are not giving you any lab-like result. They are just telling you the trend of your oil. If you
Okay.
have an algorithm for your oil, you see the trend going up, going down, going up, depending on the definition of the algorithm by the manufacturer. But in the end, you are just getting one of the parameters of the oil. For example, we are measuring some part of the visible spectra and some near infrared bands. There are other companies that are measuring, for example, the dielectric constant has been a very old or a very mature way to diagnose degradation, but now this is online, no? That is a
Mm.
different approach. I had in the lab where I was in the university, I had a very beautiful dielectric conductivity, dielectric constant measurement tool, but it had probably 30 or 40 years. But now they have switched to online, and this is offering another insights, no,
Mm.
on it. So you can use different properties of the oil to monitor the degradation, but we are not, no. There is no way to give lab-like results such as TAN, RULA, and other, or viscosity with the degradation sensor. No, with the viscosity sensor you can have it.
Okay. So that begs a few questions. Um,
Okay.
with, let's say, for example, the degradation sensors,
Mm-hmm.
how oil analysis is typically done at the moment is that we would monitor, for example, oxidation. And as that
Mm-hmm.
oxidation number goes up, we watch the trend. But for practical purposes, most people are just waiting until the oxidation number exceeds some value and then they change
Mm-hmm.
the oil. Those values, the set values or the set points, are usually determined by the OEM and they're usually attached to a warranty or something like that.
Mm-hmm.
So, with all these new sensors coming online, how are we supposed to use the data? Is it the same? We
Mm-hmm.
are going to
Very good question.
put set
Mm-hmm.
limits in, or are we just using the trend analysis? What way should companies and people be thinking of this data and integrating it into their current practices?
Mm-hmm. I think that degradation is the most easier part to explain the complete
Mhm.
process of a sensor, no? So because it's just a number, no? So your question is very good. I mean, how to transform the sensor data into user actions, no? How to decide when to do that. In
Mm.
our case, what we are doing is just getting lab knowledge into our algorithms. So we perform a degradation process for the oil in artificial conditions. We measure the samples at different conditions, and we correlate it with sensor data. So the correlation between lab reports that they have diagnostic on it and the OEM recommendations plus sensor data leads us to create an algorithm. Probably other manufacturers are doing the same, so they are just knowing when to change the oil and adjusting their values to fit in their curve.
Hmm.
So this is a way to do that. But there is another point here is that when you are online monitoring, you are always aware of your oil condition.
Hmm.
So you can decide to change it later, you can decide to change it sooner. You don't need to wait for the sample to decide this. You can see the trend. You can, if the trend is stable enough, you can decide even on 25th of May of 2025, I will change the oil because I see the trend is stable, no? Imagine, is an example,
Yeah.
no? But you are continuously there, no? You are not just waiting for the sample and seeing that the degradation has ramped up because you have a varnish on the cooler.
Mm.
So, for example, no? I mean, so it's a different approach.
So does that mean that um, if we were to set up online monitoring at a site,
Mm-hmm.
are we then correlating the sensor data with the standard lab analysis data with the view that at some point in the future, that site could maybe reduce the number of samples that it takes because they
Mm-hmm.
have now that baseline correlation between two sets of data, and that they could start to change oil based on the conditions that they see in real time. That's
Mm-hmm.
so that's how I've understand it so far. Does that need to be done on a site by site basis, that correlation, or are you guys doing correlations that would be applicable globally?
The In our case, the performance of the degradation sensors is heavily dependent on the lubricant.
Yeah.
So it's mostly a
Oh,
lubricant issue. Okay, so each lubricant has its own algorithm.
okay.
So depending on in our case, it's as I said, it's spectrometric. So the spectra of each oil is different. The
Hmm.
same with FTIR. So each oil needs a different treatment. So it's not side by side, but it's oil by oil, I would say.
Okay. Then no, that's good to know.
In fact, I would say the most advanced sensors in the degradation field, they have the feature that they have several hundreds of uh, references of oil references in their database,
Hmm.
so they can cover a very big amount of industries. So,
Okay. That makes sense.
mm,
That maybe lends itself to a question about what do businesses need to do to prepare for the world of online sensors.
mm,
It is a different skill set for one thing. It's not lube tech or a mechanic or whoever going out and trying to take a representative sample. That skill set is
mm.
not really relevant here. It's how much of the data handling does the end user need to do? Is that all on your end, or are you finding that customers will, for example, import a lot of this data into a centralized like data lake or data warehouse?
Mm.
How much cleaning of that data needs to occur? Um, so maybe you're sort of best set up to answer some of these questions.
Yes, we always start when we talk with a customer with the added value. No,
Hmm.
what are they looking for when installing sensors? Uh, Typically, the customers that are working with online sensors, they are also, or they are really aware of oil condition monitoring as a technology. No, so
Hmm.
they are trying to catch some of the issues that they cannot catch with standard oil monitoring. No, we oil sensors can reduce some of the errors that lab can have. No, for example, for contamination, the bottle that is take the sample bottle cleanliness, the human error that can occur, the practice that you just pour some oil before getting the sample in the bottle, but also especially for example for remote equipment, no, for wind turbine gearboxes,
Mm.
When you are taking the sample, machine has been stopped for several minutes. If you are climbing up, because you need to stop the turbine, you need to climb up. So how representative is the sample? No, with the online
Mm.
sensors, you are making the sample representative in all conditions. So as soon as we understand the added value, we need to check the infrastructure of the customer, or we together check the infrastructure of the customer. No, so are they prepared to have sensors on their plant or on their
Mm.
equipment? Have they a PLC, for example, no, or have they power supply, or have they wireless communication that we can use, no? So how to extract the data from the sensor and deliver it to the customer, it's a crucial point. And here
Mm.
we are very flexible. We have developed gateways to convert into protocols, communication protocols like Modbus, Profinet, Profibus, CAN bus. So these are these things that come from the automation part, but we need to be aware of that. It's not just lab reports anymore. We need to get into the field, connect to a PLC, connect to a SCADA system, but then we need to be aware of the new technologies that have appeared in the wireless field. LoRaWAN, Zigbee, Bluetooth even, or
Mm.
Wi-Fi. So you can use also these solutions. So having the infrastructure, both the physical and then so having the physical infrastructure is one thing, and then having, let's say, the soft infrastructure. So where is going to be the data? No, this is the point. Data governance is a really important topic. Cybersecurity is another important topic here, and also data maturity, or let's say maturity of data analysis from the customer. Some of customers, they just want the sensor as another signal from the equipment, such as you mentioned vibration monitoring or bearing temperature, so they can just are monitoring like this. But there are some other customers that are willing to get a bit more into the digitalization trend, so they are willing to add a new layer on that. So advanced studies about dynamic limits, uh, different studies about, for example, abnormal events. So one aspect I like to mention this because we can understand it very easily. When you take a lab sample after an unplanned event, you're just getting, let's call it, post-mortem. So you're seeing the cumulative, in the case of contamination, for example, you are getting the cumulative wear process during the complete period. So with the sensor, you have been there from the beginning. So you can see if all the wear started at the beginning, if all the wear was done at the end, which of the operational conditions during this unplanned event or this, let's say, transient event are affecting. So this is creating a new, let's say, corpus of knowledge, no, a new way to understand online conditioning monitoring data. So, as I mentioned, with some um data management, no, in terms of storing, cleansing, um, correlating, and then we can talk about artificial intelligence if you want, but it's not a. I mean, this is pretty far away, I think, for the moment. But with a good data set, you can understand better your equipment, and then there is the last point there, that it's how to transform your data, beautiful data, into user actions. Here is where it comes the intelligence that probably is available uh, in some OEMs because they have done a lot of work previously, but for most of the end users, data is still uh, not practical in all senses. So you need uh, let's say, we call it, we try always to get along with the customer during this process to make the customer understand what can they extract with the data from the very beginning until whatever, or the farther they want to go with the data. Okay.
So that to me sounds like the sort of general use cases for a lot of these sensor applications is twofold. One is from a post mortem exercise standpoint, you can fill in a lot of the gaps that we have in our data sets, because
Mhm.
obviously with standard oil condition monitoring, we might only be taking a sample once every, let's say, 3 months. In some instances, 3 months, 6 months, even
A
for
year,
gearboxes, or a
depending
year.
on the equipment.
And
Never.
if the P to effectively, if the P to F interval is shorter than your uh, interval between oil samples,
Samples.
then you
Mm-hmm.
have zero visibility on the failure mode. And this,
Mm-hmm.
even though it might be let's say, a less complete data set than a full-on lab analysis, it still gives you the regularity to be able to go through and identify when a problem event might have occurred, and when it started to
Mm-hmm.
degrade and things like that. So I think that sounds like that's one application, and the second application is more to do with trending. And once you have the correlation between the lab data and your real time data, it enables you to watch the degradation mechanisms happen in real time, and gives you an opportunity to maybe plan out and forecast when the oil change is going to happen, or something like that. Is that
Mm-hmm.
is that a fair assessment of the two main use cases, or do you see other applications for it?
Mm-hmm. The postmortem analysis, it's true. No, you are just feeling with a. I always use the same analogy. No, you have. You imagine that you want to install a surveillance system at your home. You can choose between a very good camera,
Mm,
very good resolution that you can catch the thief face, and the police automatically will go to catch him, and then you can have a very low resolution video that you see that
mm,
somebody is jumping the fence, but I don't know. So until now we just had the camera, but the camera was just capturing pictures at a random rate. No, every 3 months you are having a picture of the fence, so it's difficult to see if there was somebody getting at your getting the fence. No, with the video you can choose when to take the photo. No, you can optimize the sample rates, and also you can optimize what lab is offering you, because there is a lot of data on that, but most of the samples are okay a lot of times.
mm,
So
mm,
you are just you are just getting good results every time, and lab data also can be used to solve you an issues, not just to say okay you are fine, let's go.
yep.
So, and then the other part is what it comes to normality models. Okay, um, some companies or some equipment, let's say, have learned that you can create a core views of normal operation parameters. No, so you can have within you are in normal operation. For example, for a let's say a gas turbine, if you are at 5 megawatts power, bearing temperature is ranging from here to here. Inlet pressure is ranging from here to here. I don't know. Noise measured in the outside is ranging from here to
Mm,
here. So you can check or you can catch abnormalities in operations.
yeah.
And oil condition monitoring was lacking this part.
Mm,
So adding sensors helps you to add normality data sets into this uh, uh, normality model. No, I would then say digital twins because maybe it's a very big word and very hyping word, but you can fit oil condition monitoring data into your equipment model or your equipment, let's say, your equipment digital information.
mm,
And this
mm.
adds you or this helps you to catch more failure modes or more events, no, or more type of information.
Yeah, that makes sense. Maybe just to ask a slightly different question, about how are the OEMs responding to these new data streams? The reason I ask that
Mm-hmm.
is, I come from mainly the gas engine world, where oil analysis is king when it comes to warranty claims. So if you haven't done
Mm-hmm.
your oil analysis, and if you weren't obeying the OEM limits, then basically your warranty is junk. Uh, so with this new paradigm, where we have data sets that aren't expressed in the old ASTM or DIN formats,
Mm-hmm.
how are OEMs, let's say, using this new data set?
Okay, this is a good question. No, for example, the OEMs are thinking at the moment they are still, a lot of them are infant in the technology, no, because
Mm,
the technology is infant also. So they are finding all the ways to extract value from the implementation of this technology as a standard. For example, in the wind sector, they are in the wind turbine gearbox sector, they are advanced in this field, so they have online sensors to monitor advanced wear process. In which purpose? To get an early warning of a severe wear process. But
mm,
the PF curve, or let's say the time to failure, it's 6 months, a year, several years, depending on the robustness of the gearbox. So you are just, I would say, switching from a semi-unplanned outage to a planned outage, and you can take some action for sure. You can derate, you can improve the lube oil flow to the gearbox, or you can increase the filtration to maintain the oil in good conditions. But they are not working on this digital approach because the sensors that are available for them, they were just monitoring very late wear events. No?
mm,
But some other OEMs in other sectors are trying to use the sensors to, for example, increase the equivalent operating hours.
mm,
For example, with unplanned outages. You mentioned gas engines, but for example, in gas turbines, every unplanned outages is automatically getting you some hours of operation.
mm.
But they just give a number, 8,000 hours, 1,000 hours. Why is 1,000 hours? Because
Yeah.
they have did their test in the past, but from the experience of sensors, we know that each event is different, as in life, no? So the severity of the events can, at some point, modulate this affection, and in the end, you can have probably a more equivalent operating hours if your events are not so severe, instead of just getting out hours because you are tripping or you are stopping the turbine. So, and there are the other OEMs that are just using sensors to catch some failures that they found in the design or in the commissioning part of some equipment. So they are just using sensors to help them understand better what is happening on their equipment.
Mm. Okay. Very interesting. And maybe one last question as we sort of start to wrap up. Where do you see this technology going? Let's say if you had to
Mhm.
have a crystal ball and you could forecast out 10 years, um,
Okay.
the trend of miniaturization, I guess, will probably continue because
Mhm.
of Moore's law, and maybe the chips are able to collect more and more accurate data. But how do you see some of the implementation changing?
Let's see if there are no more semiconductor crises and so on. But yes, in the general trend, I see two ways. No, the one is to cover the gap between data information and uh, intelligence
Mhm,
on the sensor. So how to diagnose the system with online sensors? This is a I think this is in its early infants,
mhm,
because there is sensor data, there is failure data, but there is no this subject matter expertise that tell you, okay, if the sensor is doing that, you are having I don't know, hydro or micro dieseling in your equipment. No, this expertise is not still embedded, and there are some, for sure, there are some, how I would say, there are some. It's not easy to do that. No, it's not easy to transform data into actions. And the other part is the, I think it will come with the, yes, I think it will be a democratization of these technologies. Some of the customers will use it to just monitor their equipment, but some of the OEMs will start to agree to add this to their equipments, like they did with vibrations 20 to 30 years ago. So I think we will work more on the software part, and for sure, some new sensing principles can appear, or they will be more advanced. In fact, we have our own development pipeline
Mm.
where new, I wouldn't say disruptive, but new sensing technologies or sensing principles are in the pipeline at some point. So it will increase the range of application, it will increase the parameters that you can obtain. But apart from the technology development, I think there is a lot of work into uh, creating value, no, with the
Mm.
sensors.
All right, that sounds very exciting, and it's something to look forward to because it really is a bit of a new paradigm in condition monitoring, at least from the oil condition monitoring side of things.
Mm-hmm.
So, thanks to Dr. Guillermo Miro, who's obviously with Attend2 Technologies. Really appreciate your time, and thanks for sharing all your knowledge.
Thank you, Rafa, for your time. It has been a great conversation.